Alright, welcome to the second part of the basics of nutrition. We'll be exploring nutrients and recommendations. Let's start with the broad, and then we'll get more specific as we go on in this lecture and throughout the term. So you're aware that your body, your mind, you, from a purely biological perspective, are nothing more than a collection of cells and molecules and atoms that are arranged into tissues and organs. But your body is constantly changing. I mean, you are constantly changing, which is interesting because even though your cells are always changing and moving, and your tissues and your organs and all those structures that make you, I mean, those all remain relatively constant despite all this change. So what accounts for all that change, all the growth and repair and maintenance of you? And that depends on the energy that you receive. It depends on the nutrients that you receive. So what are nutrients? Nutrients are the chemical substances in food. They are used to provide energy. They can be used for structural materials. They can serve as regulating agents that would, for example, support growth and maintenance and repair of your body. They can reduce the risks of certain diseases. And think about all that for a second. What that means is that our bodies can get all the energy, all the structural material, all the regulating agents that we need to survive and thrive from food. If we were to take a tomato and we were to break it down chemically, a tomato is 95% water, and nearly all of the solid material of a tomato, nearly all of the remaining 5%, is carbohydrates, lipids, and protein, and a very, very, very small percentage would be vitamins and minerals. So in foods, we have 6 major nutrients. Water is a nutrient, carbohydrates, lipids, proteins, vitamins, and minerals. It is those nutrients that allow our bodies to survive and thrive. Energy, structural material, regulating agents. Of course, we can find other compounds in food, things like fiber, phytochemicals, pigments, additives, alcohols, etc. Some of that can be beneficial, and some of it is neutral, and some of that can be harmful. And nutrients aren't just found in the food that you eat. Nutrients are your body. If we did a chemical analysis of a human body in general, let's say it's an individual that's your age, that's about 150 pounds, young, healthy, male or female, it doesn't matter. How much of that person is water? Well, about 60% of the human body is water. That's about 90 pounds. And then there are a few differences between the sexes, minor differences. How much of a person is lipid or fat? On average, for males, this is about 20%, which is about 30 pounds. For females, this is about 25%, which is about 37 pounds. Why is there a difference in lipid percentage? Well, lipids are an energy-rich form of nutrient. They're an energy-rich food, which we're going to talk about this week and next week. If we were to look at mammals in general, female mammals tend to store more fat because females have to deal with extra energetic costs that males don't deal with. And I'm talking about some fairly significant energetic costs, which we will touch on in shades throughout this term. Reproduction, lactation, the rearing of offspring. Aside from that, the rest of the body is going to be mostly protein and carbohydrates. And of course, you get minerals that make up your skeleton, for example, calcium, and all of those other minerals and vitamins add just a fraction of a fraction of a fraction of a pound to your total body weight. But they are still important. Now we're going to look at those nutrients broadly, and then look at the macronutrients in more detail this week and next week. But before we jump into that, our bodies can make some nutrients, but we can't make all the different types of nutrients. And in fact, we can't make most of the ones that we need to survive. So the nutrients that we need to get from food are called essential nutrients. Essential, in this case, doesn't mean it's needed for your survival. Like, all these nutrients are needed for your survival. All of them are necessary. So essential nutrients doesn't mean necessary. It's not more necessary than the non-essential nutrients. Essential, in this case, means it's something that you have to get from outside. It's not something that you can make in your body. There are 3 energy-yielding nutrients. What you know: carbohydrates, lipids, and protein. Those 3 nutrients, and only those 3, provide you energy. Everything else, vitamins, minerals, water, those are all nutrients also, but they do not provide you with energy. They help you to function, they help you to regulate, they help maintenance, they help you survive. They are nutrients, but your body does not derive any energy from them. So these 3 nutrients, energy-yielding nutrients, are called the macronutrients, which we'll be spending a bit more time exploring. Our bodies need those in relatively larger amounts than the micronutrients for obvious reasons. But how is energy measured? What are we talking about when we say energy? When we're talking about energy, we're talking about calories, but more appropriately, we're talking about kilocalories. Kilocalories is a measure of energy, and so is calories, but kilocalories is what is provided to you in the food labels, despite the fact that it says calories. A kilocalorie is the energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. That is a kilocalorie. And 1 kilocalorie equals 1,000 calories. So if you look at the back of a food package, and it says that this food has 200 calories, it actually has 2,000 calories. It has 200 kilocalories. A lot of our food labels present you information in calories, despite actually referring to kilocalories. So the total amount of energy that a food item provides to you depends on the total amount of macronutrients in that food, obviously. But it's not like all macronutrients have the same amount of energy. So it depends on the proportion of each macronutrient. After that is broken down in your body, a gram of carbohydrates gives you about 4 kilocalories of energy, and a gram of protein also gives you about 4 kilocalories of energy. But a gram of fat gives you more than twice as much energy, about 9 kilocalories. Lipids, or fat, is an energy-dense food. Now, we're going to touch on that in a bit more detail, but there is one more substance that does provide your body with energy: alcohol. Alcohol is, however, not a nutrient. It does not sustain life. In fact, it actually interferes with growth, maintenance, and body repair. That being said, it does provide your body with energy. It's about 7 kilocalories per gram. And I'm not condoning anything, and if you drink responsibly. So once you get that food into your body begins to break it down. It begins to digest it. It breaks the bonds between the atoms of those nutrients. And when a bond is broken, what happens? Energy. Energy is released. That is heat. Some of that is used to deal with electric impulses, nerves, neurons, your brain. Some of that is used to synthesize compounds in your body. Some of it is used to move things around, including your muscles, to feed your body. So the energy you eat supports every activity that you do, from sleeping to thinking to activity to sports. But if the body does not need to use the nutrients for a current activity, then it can convert that into a storage compound, some of it, like fat, for example, which it can use at another time, for example, between meals or overnight when your energy supplies are low. An excess in energy results in excessive energy storage and weight gain, or a deficit in energy results in reduced storage capability, or a reduction of stored energy, and therefore weight loss. And last, the macronutrients are used in building the body's tissues and in regulating the body's activities. In this course, we simply do not have enough time to go over all of the biological and cultural and biocultural components of nutritional anthropology. So one of those components that we won't spend any time going over except in this lecture and very broadly are the micronutrients, vitamins and minerals. These do not provide energy, but they do help the body access or release energy. They are involved in regulation, in hormones, structures of our body like eyes and bones and teeth, and they have a number of other roles in the body. Collectively, they are termed micronutrients, vitamins and minerals, and they are needed in lower quantities than the macronutrients. Alright, and last, water, which is probably the most vital nutrient. It is the environment of your body. Basically, that means it's the environment in which all of your body's activities are conducted. It also has a more active role in your body, in metabolic reactions, in transportation, in cellular processes. It's involved in nearly everything that we'll be talking about in terms of the biology of nutrition. In our current society, with all of this media about what's good for you and what's bad for you, and what you should do and what you shouldn't do, and this diet and that diet, how do you know what you are supposed to eat? How much of that? What you're supposed to drink? Where did those guidelines and recommendations come from? What are they based on? I'm going to go over a few dietary reference intakes and then a few energy recommendations. First, we have thousands of studies done by private and research institutes like the University of Oregon, as well as federal organizations. And that allows nutritional experts to recommend standards that define the amounts of energy, of nutrients, and the amount of physical activity that supports health in the best way for the most people. So we're talking about average values when you look at something like dietary reference intakes and energy recommendations. You're looking at a value that's supposed to be a recommendation for the most people on average. They apply to the average healthy person and are generally not, therefore, appropriate for people with disease, a disease which may increase or decrease nutrient needs. Because these studies are done mostly in the US and Canada, at least the ones that we're going to be looking at. The results, the recommendations, apply mostly to people in those areas. These recommendations are called the Dietary Reference Intakes. Now, there is a committee called the DRI, Dietary Reference Intake Committee, and they evaluate and interpret all of these results and then make some recommendations. There are 4 main types of recommendations that they make. First is the EAR, Estimated Average Requirement. It's the requirement for each nutrient based on function, absorption, and transportation. This is population-based, and they come up with an average value, a value that's sufficient for approximately half of the population. Above the 75th percentile and below the 25th percentile, these recommendations begin to lose their value. The next dietary reference intake that you may see is called the Recommended Dietary Allowance, or the RDA. Once you have established an estimated average requirement, you have to establish the intake amount you can recommend for everyone, right? Not just most people, but everyone. You have here on this graph, you have the EAR distribution. You have a mean value, which is the closest approximation that you can get for an entire population, for everybody's needs. Every person on that graph, right? Every person in the US is supposed to be represented on that graph somewhere. The problem is, if people consume exactly the average recommended amount, right, then half the population would develop a deficiency for that nutrient, as you can see, right? Because there are a number of people that fall below and above that average value. Well, a deficiency can quickly lead to a serious health issue. So, thinking about a normal curve, the RDA sets a recommended intake for each nutrient that accounts for approximately 98% of the population. This is more of an individual-based value. In other words, you can apply it to an individual because you're trying to account for as many individuals in that population as possible without leading to toxicity or excess becoming an issue. In other words, only 2% of the population would have body requirements that would exceed the RDA, but even so, that would exceed the RDA only by a small amount. So nearly every individual will be acquiring an adequate amount of that nutrient. But what happens if you lack data? Well, then you can set up an adequate intake. The adequate intake is the average amount of a nutrient that a group of healthy people consumes. And like with the RDA, the AI can be used as a nutrient goal for an individual on the individual level. Now you might be thinking, if both the RDA and the AI can be used as nutrient intake goals for the individual, why do we need both of these? Well, again, the RDA is based on a number of studies, lots of scientific evidence supporting the intake recommendation that the needs of all people in a population will be met. The adequate intake is based more on a judgment, right? Lacking the types of data that you would need to provide a specific value, so providing more of a range. And last is the tolerable upper intake level, which is exactly what you think it is. We've gone over 3 recommendations for the intake of nutrients so far, but that recommendation may not be sufficient for every individual for every nutrient. Now, it's probably best to not exceed those recommendations by a lot or too often, but there are differences in tolerances between individuals. Regardless, somewhere beyond that recommendation level, that recommended intake level, is a point in which the nutrient can become toxic. That point is called the tolerable upper intake level. Now, it's ridiculous, it's inaccurate to think that a recommendation is only the minimum amount that you should take. No. Think of your own nutrient needs as not a point, but a range. It falls within a range. And at the ends of your range are these danger zones, areas with increasing negative effects. Knowing the upper limit is important, especially if people are playing a lot of sports, for example. And you need to consume a lot more nutrients, and maybe also dietary supplements and fortified foods. And you need to be careful about the overconsumption of nutrients. And from all of these studies on dietary reference intakes, we get energy recommendations. It's fine to have all of these ranges and limits for individual nutrients, but the problem is that some nutrients are energy yielding, right? The macronutrients. And we store excess energy, which we cannot just easily get rid of. So we have estimated energy requirements. This is the average daily dietary energy intake in kilocalories that you need to maintain energy balance and good health in an individual. And that's going to be dependent on a number of factors, and just some of them are listed up here. Age, gender, and sex. And I'm writing those two differently because they are different things. Within a cultural context, within a biological context, weight, height, the level of activity. And I'm guessing you probably know how many kilocalories is recommended for the average individual. It tends to be around 2,000 kilocalories. And the last energy recommendation I want to talk about is the acceptable macronutrient distribution ranges, or the AMDR. People don't just eat energy, right? You're not sitting there when you're eating your food and you're thinking about, I'm eating energy. At least, probably not typically. People eat food, and food happens to have energy, right? It has macronutrients in various quantities. But how do we know how much protein or carbohydrates or fats to eat? Well, the AMDR recommends intake ranges for the macronutrients, ranges that provide adequate energy but also reduce the risks of chronic diseases. For carbohydrates, the range is between 45 to 65% of your total kilocalories. For fats, it's between 20 and 35% of your total kilocalories, and for protein, between 10 and 35%. Those are supposed to add up to 100%. So 100% of your energy, right? But coming from the macronutrients in those proportions. Now, with all of this background, it sort of lends itself to talking about energy, diet, and balance, which I want to talk about next week. But I do want to clear up a few misconceptions about all of that. First, intake recommendations apply to healthy individuals, right? They are estimates, and as estimates, they need to be adjusted for various people for various reasons. Malnourishment, medical problems, dietary sensitivities, sports, etc. And I've already said this, but I'm going to say it again because it's important. Recommendations are not minimum requirements, and that means they are not necessarily optimal intakes for all individuals. Recommendations, at best, only target most people, or the average, but it cannot account for individual variation in nutrient needs. Third, most nutrient goals need to be met through a diet composed of a variety of foods, because foods contain a mixture of nutrients and non-nutrients. And that means they deliver more than simply nutrients that would be covered by a recommendation. In other words, you can eat as many fruits and vegetables as you want to get vitamins and minerals, because an excess of vitamins and minerals through food is very unlikely. Also, different fruits and different vegetables have different vitamins and different minerals, and in different proportions. But once you begin to supplement that, dietary supplements for example, you increase your risks of toxicity. 4, and this is important, recommendations apply to the average daily intake. And that means that trying to meet the recommendation for every nutrient on every day is not only unnecessary, but stressful and difficult. There is variation between individuals. There is also variation between nutrients, which depends on how the body uses and stores a nutrient. For many nutrients, having an inadequate intake, a deprivation, will lead to the development of a deficiency or deficiency symptoms fairly rapidly. Could be days or weeks. Thiamine, vitamin C, for example. For other nutrient deficiencies, only develop over months or even years. Vitamin A, for example. Vitamin B12, for example. And last, each of those DRI and ER categories has a purpose, and one that is specific and different from the others or unique to itself. Don't confuse all of those. And I don't just mean that in terms of your quiz next week, but if you hear someone talking about an EAR, don't just assume that those values applies to you, right? Understand what it is, but know that there is variation involved. Now, what I've got up here is more of a thought experiment. You don't need to know any of this material for a quiz. I just want you to think about nutritional anthropology. Food obviously plays a significant role in health. And all of those recommendations that we talked about are about maintaining good health, about finding a perfect balance between under and over nutrition, and then maximizing the health benefits of food for your body. The link between nutrition and health has formed some of the most early studies that would be termed nutritional anthropology, looking at nutrients in food that could help prevent common diseases like rickets and scurvy, vitamin D and vitamin C, right? And even recent studies look at links between chronic diseases and nutrient excess. Now, in fact, chronic diseases are responsible for 7 out of every 10 deaths among United States adults. So on this slide, I've got a table showing the 10 leading causes of death in the United States from 2012, the Center of Disease Control and Prevention. Now, one thing about this table, all these causes are listed as an isolating factor, right? For example, heart disease. Here it causes 23.7% of total deaths in the U.S. Heart disease was the cause of death for those individuals. But many chronic diseases are the result of a multitude of factors that develop over many years. For example, an individual may have died from heart disease. That's a fact. But that person may or may not have been overweight, may or may not have had high blood pressure, may have smoked cigarettes, may have eaten a poor diet, high in saturated fats for most of their life. They may or may not have exercised much. It could be a combination of some or all of these factors. Now, of course, not all people who die of heart disease would fit a negative description like that, and not all people with those descriptive characteristics will die of heart disease. Someone may instead die of complications related to diabetes or cancer, or from something completely unrelated, like an accident. But studies, time and again, show that certain behaviors and certain conditions are linked to certain disease. So back to this table that you're staring at. You can see that 4 of the top 7 leading causes of death among adults here in the U.S. have a link with diet: heart disease, cancer, stroke, diabetes. Those 4 account for more than half of all deaths each year. With a chart like that and understanding the relationship to food and diet and nutrition, how do we reduce disease risks and promote good health? Well, traditionally, we did this through a graphic known as the food pyramid, and I'm guessing that you know about this. I remember when I was going to elementary school, we had charts depicting this up in the classroom, and we actually studied that. That you would need a certain number of servings of bread, cereal, rice, and pasta. You had a vegetable group, and you needed a certain number of servings per day, and fruit group, a certain number of servings. And as you go up the pyramid, you need less and less servings of each of these different groups. There are a number of issues with the food pyramid. First, it is consumer designed, in terms of the basic shape. Why is it a pyramid? Well, that suggests that some food is better or healthier and should be eaten more often, and other food is not as good or healthy and should be eaten less often, as you get these layers representing major food groups that constitute the overall diet. The problem with this US Gov USDA designed food pyramid is that it gives the wrong dietary advice, but it's also vague and confusing, right? It says 2 to 3 servings. Well, what is the serving size anyway, right? Think about that. You see the guide and you think, great, I'll eat 2 to 4 servings of fruit, 3 to 5 servings of veggies, 2 to 3 servings of meat. But my guess is that most people will eat 2 to 3 servings of meat each time they go to eat a serving of meat, because there's no recommendation for the serving size. A serving of meat is about the size of a deck of cards. All right, that's a full serving. In fact, that's all you would actually need for a day. My guess is that when you order a hamburger or you cook a hamburger, it's probably more like 2 or 3 times that size, and probably inverted for fruits and vegetables. If you order a serving of fruit and vegetables, or you take a serving of fruit and vegetables on your plate, you might only put about 2 to 3 times less than what is an appropriate serving. Next is carbohydrates. Carbohydrates in the pyramid are presented as the base. But are they really all the same? I mean, the food pyramid recommends 6 to 11 servings of carbohydrates a day, which is way too much. It also doesn't differentiate between 2 kinds of carbohydrates: simple carbohydrates, known as sugars, and complex carbohydrates, starches. The majority of a person's carbohydrate intake should come from whole grains, complex carbohydrates, which will make you feel fuller longer and gives you a lot of fiber, which is important for your body as well. Now, let's go to the other end of the pyramid: fats. All fats are bad. Use sparingly, it says. But what? Only certain fats are actually bad for you: saturated and trans fats. Others, monosaturated, polyunsaturated, provide many benefits to your body, including your heart, are important, essential to keep your body alive and functioning. Next, group selection is misleading in this food pyramid. Protein is a good example. not all protein is actually good protein. Some meat, like red meat or steak, is also high in cholesterol and in saturated fats, which are not good for your heart. Some processed meats form cancer-causing compounds, like bacon, ham, pepperoni, hot dogs, hamburgers. These are now classified as a Group 1 carcinogen alongside of solar radiation, mustard gas, cigarettes, and 180 other substances that are linked to increased risks of cancer, male infertility, early death, etc. Now, having ranted on that for a bit, some protein is, of course, excellent, great. Fish, chicken, turkey, pork are lower in saturated fats and have just as much protein as those other meats. And protein doesn't only come from meat. You can get the protein you need from other sources. Dairy represents another example of the confusing nature of group selection. Well, first off, in the early 90s, when this food pyramid was being used, ice cream was included alongside of milk in the dairy section, or the dairy group. These are not comparable in terms of their nutritional value. And second, dairy is not essential to your body. Why have dairy up there at all? And think about this. The reason from a nutritional perspective, and I won't go into consumerism right now, but the reason is that dairy is a source of calcium. And then you get all those commercials, right? They talk about how milk makes your body and your bones strong. You know, milk makes you good and better. Well, first, our country gets more calcium per person than any other country. People are intaking more calcium than they need. Along with that, there are studies that show that an excess in calcium intake contributes to a variety of cancers, prostate cancer in males, ovarian cancer in females, for example. And second, you don't need dairy products to get calcium in your diet. You can get calcium from other foods like spinach and tofu and orange juice and broccoli, etc. So it's biased. A large percentage of the world population that does not have lactase persistence cannot digest dairy products, at least to some degree. And last, where is the guidance beyond nutrition? So if you just eat according to the pyramid, you'll be healthy? Is that what that pyramid is really implying? That may be true for a healthy diet within a healthy lifestyle, but there are other key parts to leading a healthy lifestyle and having a healthy body, right? You need something that highlights the importance of weight according to a number of other factors, such as gender and sex and height, etc., the necessity of daily exercise, and the importance of the micronutrients. If the food pyramid doesn't work or has a number of inherent problems, what is an appropriate diet plan, and how can we visualize that? First is adequacy. That is having a diet that provides sufficient energy and enough of each of the nutrients to meet the needs of most healthy people. For example, iron. You probably get this in your diet or through supplements, but what happens if you're not eating enough foods with iron and you're not taking supplements? Well, that leads to a deficiency in iron. You feel exhausted, you're tired, you're weak, absent-minded, headaches. To prevent those symptoms of iron deficiency, you would simply need to eat more foods with iron. Next is balance. You want a balanced diet so you can ensure adequacy. And there are some overlaps between each of these categories, obviously. The art of balancing your diet is, I think, difficult for some people. And that's why we have nutritionists. you want to consume enough but not too much of different types of food so that you are not just eating foods rich in some nutrients, but you get all the nutrients that your body needs. For example, your body needs iron, but your body also needs calcium. If you eat meat, that's great. It's rich in iron, but it doesn't happen to be rich in calcium, so you might drink a glass of milk. That's also great. It's rich in calcium, but it's not rich in iron. So you eat a portion of meat, but not too much, and that gives you some iron. You drink a portion of milk, but not too much, and that gives you some calcium. And you have room, right? You've saved space because you're eating smaller portions, right? Saved space because you need to eat other foods along with that too, because milk and meat as a diet is inadequate from a nutritional perspective. Kilocalorie control is also important. We need to design a diet with a reasonable kilocalorie input. And this relates to balance, right? Because you need to balance the amount of energy coming into your body with the amount of energy being used by your body. Not just for our metabolic processes, but also for all of these other components that we'll look at next week. For example, physical activity. And one good way to do that is to choose foods that have a high nutrient density. And that is the next thing I want to talk about, high nutrient density. Remember, we talked about lipids as being an energy-dense food. And that is what this means. Although we're not talking about energy, we're talking about nutrients. It means foods that deliver the most amount of nutrients for the least amount of food energy. So you can eat well without overeating. Here's an example. Calcium. You get about 300 milligrams of calcium in 1.5 ounces of cheddar cheese, or in 1 cup of low-fat milk. Now, the cheese tastes good, right? For some of us. That cheese has about twice as many kilocalories, or food energy, as the milk. So the milk is more nutrient dense. It offers the same amount of a nutrient, calcium, for half of the kilocalories. Now, there are levels involved, as you're probably beginning to see. Both the milk and the cheese are fine in terms of adequacy or balance. But to achieve adequacy and balance, while also controlling for kilocalories, then you want to choose nutrient-dense foods. And in that perspective, the milk is a better choice than the cheese. I think that concept is probably easy enough to understand, but I just want to provide another example. Here's a rhetorical question, obviously. On one side of the screen, you have a breakfast with cereal, fruit, egg, and sausage. And on the other side of the screen, you have a breakfast with donuts. Both of them come with a cup of coffee. Now, both of these breakfasts add up to the same amount of kilocalories. But the cereal, fruit, egg, sausage brekkie delivers a lot more nutrients than the donut, or the donuts. It has more protein, more fiber, more vitamin D, more calcium, more potassium, etc., etc. And there is a lot more food there. So you eat more, you get more nutrients, and for fewer kilocalories per weight. The donuts, on the other side, are more energy dense. More energy in less amount of food. And this whole concept is relative. So the milk is nutrient dense in terms of calcium compared to meat, but the meat is nutrient dense for iron compared to milk. So we can talk about adequacy and balance and kilocalorie control, but an appropriate diet plan is also about moderation, and that is something that can be difficult for people. Moderation contributes to all of those above factors. Foods that are dense in fats and sugars, or preferably both, taste great. And a lot of you talked about this in your introduction post. They give people enjoyment, or they can give people enjoyment. And they also provide energy, but they are not nutrient dense, and they can lead to an excess in macronutrient, specifically lipid, storage, and that can lead to weight gain. You can eat these foods, but in terms of nutrition and weight management, they need to be eaten in moderation on occasion. And the last aspect of an appropriate diet plan I want to talk about is variety. Variety improves nutrient adequacy. A diet could have adequacy and balance and control and moderation and still lack variety. For example, you have the perfect breakfast, lunch, dinner, snacks, and you have all of this planned out. And say you eat that day after day after day. It's important that you vary the foods that you use to fulfill not only the food groups, but the nutrient requirements. And part of the reason is that different foods within each group contain a unique mixture of nutrients. So you might have your fruit group covered with strawberries, right? Which is great. Strawberries are a fruit. They're rich in vitamin C. But you can mix it up a bit. You can eat one day apricots, which are not rich in vitamin C, but they're rich in vitamin A, right? Variety is a great aspect of food, and a lot of you also mentioned that. If you like fruits, you should mix it up. Don't just stick with one type. And all of this adds up to a diet plan that the USDA suggests, and one that is more variable and flexible and appropriate now than it was in the past for more individuals. The average recommended daily kilocalorie intake is about 2,000 kilocalories per day on average. Now, it varies according to a number of reasons, but for a quiz situation, 2,000 kilocalories is the number you'll need to know. You can see in the chart on the bottom of this slide that for a 2,000 kilocalorie diet, a person would need to ingest 2 cups of fruit, 2.5 cups of vegetables, 6 ounces of grain, 5.5 ounces of protein, 3 cups of dairy, small amounts of oils, etc. But they have different recommendations here for different amounts of kilocalorie intake based on a wide number of variables. Let's stop there for this lecture, and you can go ahead and continue with the next lecture.